Hello, and thank you for joining us today. My name is Kobi Magnezi. I'm product manager for GKE. And today I would like to share with you some of the best practices on how to leverage GKE to power a competitive IT e-commerce infrastructure. First, let's start with looking at some of the drivers for e-commerce organization and the requirements they imply for the supporting infrastructure. In a recent validation study of Google Cloud Solution for e-commerce, the ESG analysis found that retail industry is focused on providing better and more differentiated customer experience through specifically digital transformation initiatives, with about 50% of retail organization strategically prioritizing this objective. For retailers, creating an e-commerce presence increase not just the touch points with the customer, but also the sales opportunity, especially when event like the pandemic pushes more customers to online channels. At the same time, it also increases the competitive landscape. To maintain the competitiveness, an e-commerce infrastructure must provide one, high performance, two, scalability, three, reliability and availability, four, customization and innovation, and finally, flexibility. Let's look deeper into these areas to understand how Kubernetes and GKE address these areas. We will also provide some recommendation for configuration and options that you would want to consider for your cluster. Many customers use GCP to migrate, modernize, and improve their deployments. GCP infrastructure and networking are powering GKE. So when you create a Kubernetes cluster on GKE, we provision the machine and the resources needed for GKE to properly run your cluster's control plane and nodes on GCP. The Kubernetes cluster control plane is fully managed by us, backed by an SLA. We will keep the control plane up to date and will scale it automatically up and down when cluster size changes. For efficiency and high performance, you can choose what type of machine, what machine configuration best meets your needs for your different node pools. And as demand changes over time, so does the load on your e-commerce workloads. Scaling is necessary to ensure that GKE grows to match your need. Think about number of pods, number of nodes. GKE includes several auto-scaling capabilities that will automatically resize your cluster based on your configuration and signals that we monitor. HPA, for example, automatically increases or decreases the number of pods on your cluster based on utilization. With VPA and NPA, you can enable vertical scale for both your nodes and pods. And if capacity planning is part of your practice, especially for peak season like Black Friday, Cyber Monday, or New Year, you may want to reserve GCE capacity. With GCE reservation, when your GKE cluster requires to scale, repair, or upgrade, it will have a reserved pool of dedicated resources available for the performance. You can also create specific or non-specific reservation, and GKE will create new resources based on the pool that you reserved. Now let's talk about availability. And it's important to distinguish between application availability and infrastructure availability. The availability of the business application, which the customer interact with, and the availability of the infrastructure, which hosts and support the application. On the application side, the impact of insufficient availability can be unresponsive e-commerce website or unreachable service. On the infrastructure side, the impact can happen at different levels. At the cluster level, for example, when node become unresponsive or when pods get rescheduled, at zone level or at regional level, where there is a connectivity issue, for example. While both the application and the infrastructure impacts the overall availability, it is actually the business application that drives the decision around redundancy, deployments, and architecture. With this definition in mind, it is important to understand how GKE is structured as a shared responsibility product. The data plane, the nodes where the e-commerce workloads are deployed, are the most critical piece for customers, as any reliability issue can directly impact the business. The Kubernetes control plane is the next most critical piece, as it's responsible for scaling, repairing, and managing the deployments. And then most of the workloads deployed on the data plane can probably survive an outage, a short outage of the control plane without too much impact. The GKE control plane on the leftmost side is the least critical piece, as they are mainly focused on the operations and the management of the GKE control plane. Let's look on the two most important pieces from a reliability perspective. Both control planes and nodes can be provisioned in a single zone, a zonal cluster, as illustrated on the right side, or can be provisioned in 3 different zones within a region, a regional cluster. There are some cases where zonal cluster topology better serve your needs and constraints. We do recommend, however, to use regional cluster for highly available Kubernetes infrastructure, especially for production workloads. For control planes, the redundancy provide high availability and in turn provide higher SLA for the Kubernetes API. But besides of the API availability, the API availability in the control plane doesn't really impact the workloads themselves necessarily. The control plane is also responsible for maintaining the cluster with scaling, repairing, and other vital operations. And you may want to take into consideration, based on the nature of your e-commerce workloads and needs, the type of topology that is right for your architecture. Since we provision compute resources on GCP for the Kubernetes clusters, node availability are based on the compute engine availability for instances provisioned in a single or multiple zones. Finally, the availability of your application is closely tied to the node availability, as you can imagine. And luckily, Kubernetes offers an easy way to create multiple instances of your application for higher availability. One great way to secure higher availability for your application and also to reduce potential disruption is the use of PDB, or pod disruption budget. PDB allows you to state your disruptions tolerance. In other words, if your application is replicated, you can specify the minimum number of replicas that can be disrupted when maintenance even happens. In the example that I have on the slide here on the right side, we specify that we cannot tolerate less than 2 replicas of our application. This is just another way of saying max unavailable equal 1 in case we have 3 replicas of the application. GKE respects PDB up to 60 minutes and termination grace policy up to 60 minutes. When a security patch or Kubernetes update is rolled out on your cluster, GKE will perform the upgrade in a way that satisfies the PDB configuration. The other thing that you want GKE to know about your workloads is what consideration it needs to apply when it schedules your pods on different nodes in the cluster. By default, GKE and the Kubernetes scheduler automatically spreads your pods across the nodes, whether it's regional or zonal cluster. However, some e-commerce application and specifically stateful workloads, like Redis, for example, require a quorum of servers to successfully work in a redundant deployment. Without specific instruction, Kubernetes may decide to collocate all the pods for your stateful application, stateful set, on the same machine, on the same node, and basically create a single point of failure and risk to the availability of the e-commerce application. Exactly for those reasons, we can use pod anti-affinity to ensure pods are not scheduled on the same specific node if we set the criteria. So if I require a quorum of servers to properly operate a stateful application, for example, I would want Kubernetes to refrain from scheduling all the replicas on the same machine. So if something happened to that machine, it won't take down all the different replicas of my application. On the flip side, there are some applications, workloads that may actually benefit from being co-located on the same machine. For example, if you have a web server and you want to co-locate it with a cache service for better performance and lower latency. In this case, you might want to use pod affinity. Another important aspect of the infrastructure reliability is monitoring and specifically providing accurate signals to Kubernetes about your workload state and health. The first signal in this slide is readiness probe, which basically defines a signal for when a workload is ready to serve traffic. Say, for example, if a workload takes some time to start, the lack of such signal may lead to Kubernetes starting to send traffic to a not yet ready to respond workload, which will lead to timeout and impacted experience. The second signal here is liveness probe, which provides a health signal that Kubernetes uses to determine whether it should initiate a repair and replace of a faulty instance or not. Defining an upgrade strategy for your cluster is another important dimension of reliability. A new Kubernetes minor version is released roughly every 4 months from open source, and patch versions are released more frequently. Because the Kubernetes clusters contains both control plane and nodes, there are two places to manage when it comes to keeping your clusters up to date with releases, security patches, and bug fixes. Luckily, GKE offers different ways to keep your cluster's infrastructure up to date. Being a shared responsibility product, GKE keeps control plane automatically updated. And alternatively, you can keep your node version upgraded automatically or initiate the upgrade manually by running your own script or using our API. To ensure that your infrastructure is up to date and also being kept as such in a safe and non-disruptive way, we highly recommend the use of multiple environments. So when there is a new version or a patch, it can be rolled out for testing and qualification on staging and testing environments before it hits the production environments. In general, we recommend to use the same version in all environments, so you get consistency and correctness of your qualification process. However, you may want to consider a second development environment where newer releases can be tested. This can be useful when a new GKE feature or Kubernetes API are being introduced and you want to test them to get a head start and be ready for the market when you have a new feature that rely on this capability. The process of upgrading your Kubernetes clusters, keeping the control plane and nodes preferably in sync when it comes to the same version, and also in a supported version, and also in a supported version SKU that is mandated by open source. That process can be toily and very cumbersome. And one way to simplify it is by using release channel. Release channel in GKE allows you to choose your upgrade path and also control the type of upgrade that will be applied on your cluster. Some customers may want to use the latest Kubernetes version because, as I mentioned before, dependencies on a new API or capability, or maybe they have a specific business objective. In this case, you may want to use the rapid channel, which is closer to open source in terms of releases. Other customer may prefer stability over functionality. And in that case, they would choose either the stable channel or the regular channel, which are the ones we recommend for production workloads. When it comes to patching or upgrading your cluster, the nodes where the e-commerce application are deployed, we replace them. Those nodes are being replaced with new provisioned machine running the newer Kubernetes GKE version when an upgrade takes place. When nodes are replaced, as you can imagine, pods running on them are gracefully shut down so the node can be drained and replaced. On the GKE side, node upgrade used to follow the workflow of delete, then create, meaning that when we upgrade, GKE used to drain a node, delete it, and then replace it with a new one. However, to increase the availability and also to reduce disruption, node upgrade is now happening through surge upgrade, where we change actually the order. We first create a new node for the upgrade, and only when that node is ready and available, we gracefully drain the old node. Not only that surge reduce disruption to existing nodes, it also allows you to control the number of nodes that can be upgraded currently. The default setting is one node at a time. So keep that in mind. If you are using large clusters with many nodes, you probably want to change that number so more nodes can be concurrently upgraded at the same time. It is clear that sustaining a competitive e-commerce infrastructure requires a continuous upgrade practice. However, as we all know, sometimes business requirements may change, especially when disruption simply cannot be tolerated. For example, think about peak seasons like Black Friday, Cyber Monday, New Year, or major company events, trade fairs, or something like that. We recommend you to use exclusion window for this event. With exclusion window, you can specify a range of dates in which you want to refrain completely from any type of maintenance. You can also set up maintenance windows to specify when you prefer maintenance to happen. This can help you to improve predictability of the upgrade and also allow to control the time of the upgrade on different clusters. Exclusion windows and maintenance windows can greatly help you control the disruption and reduce risk. But we've seen with many retail customers that they are actually experiencing different requirements during different time of their fiscal year. For example, an e-commerce infrastructure is most likely to follow some regulation or compliance like PCI, for example. And these compliance have specific guidelines when it comes to keeping your software up to date and how frequent and fast a new security patch should be consumed. In this case, I might want to allow all type of upgrades and patches on both control planes and nodes throughout a low season month. While during high peak season, like Black Friday, Cyber Monday, I want to refrain completely from any type of maintenance, so my workloads will not be affected. And then also in some other cases, I might be okay with just patching my clusters, both nodes and control planes, but would want to refrain from upgrading to the next minor version. We believe that this level of flexibility is actually needed for e-commerce infrastructure, so they can control maintenance events and also the risk level associated with the change in accordance to their business needs. This way, you can delegate all patching and upgrades to GKE while being able to instruct it on what type of upgrades you want to allow, the scope, and when to initiate a process. So now that we know how upgrades and patches get rolled out, I think it's important to also stay informed and know about changes coming to your clusters. One place to learn about GKE releases is, of course, the GKE release notes page, which includes links to the release schedule and the version support policy. But we also recommend the use of GKE notification, which includes notification for upgrade and upgrade available events. GKE notification, which is based on PubSub, you can listen to upgrade available events, and which when they fire, indicate that there is a newer version or patch available for your cluster. In turn, you can use that event and trigger a workflow to apply these patches, for example, on your testing cluster. So the infrastructure version can be vetted and qualified before it gets released to your production environment. Finally, a robust e-commerce infrastructure must also provide some flexibility, so you can apply some changes on the fly in a non-disruptive way. We've identified several common places where changes involve disruption, because when you apply these changes, it actually requires us to recreate the machine or node pool. For example, you may need to change network tags in order to change firewall rules or routes to your e-commerce application. You can now do so. You can change network tags for existing running VMs without us recreating the VMs and basically applying this change on the fly. The same thing goes for node taints, which you can use to steer away pods from specific nodes, or labels, which are used to schedule pods on particular nodes. All these three options are now modifiable without requiring recreation of the machine. So we've learned from the ESG report that there are specific areas an e-commerce infrastructure must cover to maintain competitiveness. High availability, where redundancy is important to avoid single point of failure. That applies to both control plane and nodes. Scalability, use multiple replicas, the use of PDB to avoid disruption, affinity and anti-affinity to better instruct the Kubernetes scheduler on how to optimize the deployment of your workloads. Reliability and availability. Remember that control planes are fully managed on GKE, but can go through maintenance. Make sure that you don't create unnecessary dependencies on the control plane API in your application to avoid disruption to your application when control plane is being upgraded. And then finally, for flexibility, there are some changes that can be applied on the fly and do not impose any disruption for existing workloads. To close up, I want to share a quote from Lablo, a GKE e-commerce customer, who achieved great success using both GCP and GKE despite going through the unexpected challenges of the pandemic. Lablo migrated and modernized its e-commerce with GCP and GKE, and also leverage the Black Friday Cyber Monday white glove service for additional peace of mind during this critical business period. This resulted in better performance at scale, faster application development and deployment, high availability, and elimination of Black Friday Cyber Monday outages. And while keeping the infrastructure up to date, Lablo managed to leverage the different infrastructure capabilities to roll out their COVID-19 vaccines delivery system in 9 weeks instead of 18 months. There's much more to learn. You can download the full ESG report from the first link on this page and find more documentation and best practices on the GKE website on the second link. Thank you so much for watching this session. I hope you enjoy the rest of your Google Next.